In this session, we are going to talk about what is exactly the process that VXLAN follows in order to perform layer 2 forwarding. In order to show how VXLAN actually works, we are going to use this case. Device A and device V, they both live within the same broadcast domain. Now the first step will be configuring the same VLAN. So we are going to use VLAN 10. We are going to configure VLAN 10 here in this device and this device, and we are going to associate these ports as belonging to the VLAN number 10. They are regular access ports. Now for the next step, we are going to actually start doing some VXLAN configuration. We are going to declare a VXLAN network ID, and we are going to map it to a traditional VLAN number. We are going to do so at each VTEP, and we are going to use the same mapping. So for instance, we are going to map this VXLAN network ID 101010 to the VLAN number 10, and we are going to do the same at every single VTEP. Given we are talking about a layer 2 forwarding, we are going to call this a layer 2 VNI. Now, device A wants to send a frame to device V, so they are both in the same VLAN. So we are talking here about a layer 2 forwarding case, and given they are in the same broadcast domain, we are not even talking about a default gateway yet. Now let's say that device A wants to send a frame to device V, so the frame arrives to this particular switch that we are going to call VTEP X. VTEP X needs to encapsulate this frame and forward it to the appropriate destination. So it needs to know what is the destination IP address, what is the destination VTEP. So in this case, the control plane is going to figure out what is the destination IP address. So the control plane is going to answer that question, and now VTEP X will know that the destination device V is connected to VTEP Y. So VTEP X is going to create a tunnel destined to this particular IP address, because that is the ID for this destination VTEP. So it is going to encapsulate the complete frame that is just received within a VXLAN, using a VXLAN encapsulation. Remember that we are going to use an IP header, a UDP header, a VXLAN header, and notice that the destination IP is the IP of the destination VTEP, and the source IP is actually the ID of the sender VTEP. This is known as MAC to IP processing. Now, in order to build the VXLAN header, remember that we must specify a VXLAN ID. We are going to use the layer 2 VNID that we previously mapped to VLAN 10. So we are going to use this number 101010 as the VXLAN ID that we are going to include to build this encapsulation. After building the packet and sending it, the layer 3 network is going to be the transport. So all these devices in between are going to just transport this packet from source to destination. Now, upon arrival, VTEP Y is going to notice that it is actually a VXLAN packet, because it is going to see that in the destination port for this UDP header, and then it is going to examine what is inside the VXLAN header. It is going to notice that it is including this VNID. Given this destination VTEP has already this mapping between this VNID and the VLAN 10, it is going to know that this frame belongs to VLAN 10. It is going to de-encapsulate it, and it is going to forward it to the destination device that is connected to it.